Hello, my name is Dury Long, and I am a human-centered computing PhD student working in the Expressive Machinery Lab at Georgia Tech. My advisor and co-author is Dr. Brian McGurko. Today, I'm going to be talking with you about our paper, which is entitled, What is AI Literacy? Competencies and Design Considerations. Artificial intelligence is becoming increasingly integrated in user-facing technologies in our homes, workplaces, and schools. But there are still a lot of existing questions and misconceptions about what AI is, how it works, and how to use it. These types of misconceptions can limit people's ability to effectively use, collaborate with, and act as critical consumers of AI technologies. There is a need for additional research investigating what new competencies and design considerations will be necessary in a future in which AI transforms the way that we communicate, work, and live with each other and with machines. In other words, there is a need for improved public AI literacy and a better understanding of how to design technologies and learning experiences that can promote AI literacy. The term AI literacy is used loosely in a few papers, but has not been clearly defined in the literature as of yet. We present a working definition of AI literacy as a starting point for research in this area. We define AI literacy as a set of competencies that enables individuals to critically evaluate AI technologies, communicate and collaborate effectively with AI, and use AI as a tool online, at home, and in the workplace. We see AI literacy as being related to but distinct from other previously defined literacies, such as scientific literacy, data literacy, digital literacy, and computational literacy. While we see these all as being related, we see scientific literacy and computational literacy as being able to inform AI literacy, so maybe being helpful for AI literacy, but they're not necessary prerequisites. So for example, individuals can learn key concepts about AI without necessarily needing to know how to program. Digital literacy, on the other hand, is required for AI literacy, as you need to have a familiarity with computers and technologies to be able to understand AI. And we see data literacy as having a significant overlap with AI literacy, particularly in relationship to understanding the AI subfield of machine learning. All of these literacies have emancipatory consequences, potentially broadening access to knowledge and the ability for people to share and communicate ideas. But what are the competencies that make up AI literacy? And how can we design technologies and learning experiences to promote those competencies? These are the primary research questions that were driving our research in this paper. In the past few years, there's been some initial research into similar questions, such as how to teach AI to K-12 students. The working group AI for K-12 has developed a set of 5 big ideas of AI that can provide an initial basis for exploring AI education for learners who don't have technical backgrounds. For example, the idea that computers learn from data, or the idea that computers perceive the world using sensors. This group is working to develop a set of standards for K-12 education. In addition, there have been books published on practical strategies for teaching AI in K-12 classrooms, such as Michelle Zimmerman's Teaching AI, and researchers at MIT have developed an AI ethics curriculum for middle school students. Several industry partners have also been working on developing AI curricula, including the companies Ready AI and AI for All. There's also some existing research that is focused on designing tools and technologies that enable individuals without technical backgrounds to learn about AI. There are interactive web demonstrations that offer insight into AI's reasoning processes, such as Google's Quick Draw program, which allows individuals to inspect how a neural network interprets human-drawn doodles. There are a variety of toolkits that allow individuals to tinker or learn by interacting with and programming commercially available AI devices, such as Cosmo or Alexa. For example, Cognimates, ScratchNodes ML, and Calypso for Cosmo. All of this research provides a great foundation for understanding AI literacy and how to communicate it to non-technical audiences. However, most of this research is really recent, from the past 2 or 3 years. In contrast, AI as a field has been active since the 1950s, and there's a variety of existing research scattered across disciplines and venues that could potentially contribute to understanding what competencies should be included in a definition of AI literacy and how to better design educational experiences that foster AI literacy. Towards this end, we engaged in an exploratory review of literature with the goal of distilling ideas from various fields that could inform our understanding of how learners make sense of artificial intelligence. Due to the limited amount of existing peer-reviewed literature on AI education and the variety of research in related fields such as CS education or human-computer interaction that can inform AI education, we did not conduct a traditional systematic literature review. Our methods were instead more closely aligned with an approach called scoping studies, which aim to map rapidly the key concepts underpinning a research area and the main sources and types of evidence available, especially where an area is complex or hasn't been reviewed comprehensively before. Our review was guided by two key questions. First, what do AI experts think that non-technical learners should know about AI? And second, what existing perceptions and misconceptions do non-technical learners have when interacting with AI? The literature we reviewed in response to these two questions included 150 documents on topics including explainable AI, data literacy, AI education efforts in K-12 and university environments, human-robot interaction, AI ethics, and public perceptions of AI. These documents spanned over 20 years of research and ranged from peer-reviewed conference and journal papers to gray literature such as public polls, classroom syllabi, and textbooks. More details on the methodology of the literature review can be found in the paper. We distilled a list of key ideas presented in the literature and grouped them based on similarity. We distilled competencies and design considerations from this list by considering whether the ideas reflected our definition of AI literacy, were supported by multiple sources, and whether the ideas were useful guidelines for designers and educators. We then sorted the design considerations and competencies that we derived into thematic groups, forming the conceptual framework that you see on the slide here. This chart shows all of the competencies and design considerations that we distilled from the literature, grouped according to 5 themes. What is AI? What can AI do? How does AI work? What should AI do? And how do people perceive AI? In the following slides, I'm going to present a few competencies and design considerations from each of these themes, but due to time, I can't cover them all in this presentation. Please refer back to this slide for a full list of the competencies and design considerations, and to the paper for more detailed descriptions of each competency and design consideration and how they were derived from the literature, including supporting references for each one. So first, I'm going to start by reviewing a few competencies from each of these thematic categories. Within the theme, what is AI? One of the competencies that we identified is that AI literate learners should be able to recognize that AI is interdisciplinary and that there are many different ways to develop intelligent machines. Learners should be able to identify a variety of different technologies that use AI, including technologies spanning the 3 areas of cognitive science, robotics, and machine learning, which are the subfields of AI. Within the second theme, the space of what can AI do? We suggest that learners should be able to identify problem domains that AI currently excels at and domains that are currently more challenging for AI in order to determine when to leverage human versus AI skills. For example, AI is really good at recognizing patterns in large amounts of data, but it can have issues and struggle with sort of encoding bias into its analyses. So it's important for learners to be able to distinguish those strengths and weaknesses. We divided the theme, how does AI work, which is a really big question, into competencies relating to cognitive systems, machine learning, and robotics. Again, the 3 main subfields of AI. One of the competencies that we identified for cognitive systems specifically was the ability to understand what a knowledge representation is and describe some examples of knowledge representations. This could potentially aid learners in distinguishing between how humans represent knowledge and how computers represent knowledge. Within the space of machine learning, one of the competencies that we identified was that it's important to recognize that humans play a role in programming, choosing models, and fine-tuning AI systems. And finally, within robotics, one of the competencies that we identified was the understanding that AI systems are able to physically act on the world, and that this action can be directed by higher level reasoning, such as walking along a planned path, or it can be reactive, such as jumping backwards to avoid a sensed obstacle. Within the space of how should we use AI, the next sort of thematic category, we suggest that learners should be able to identify and describe different perspectives on the key ethical issues surrounding AI, which we outline in more detail in the paper. Some of these ethical issues might include privacy, accountability, bias, or fairness. Finally, within the space of how people perceive AI, we suggest that learners should understand that agents are programmable, a concept that younger learners especially may struggle with as they tend to personify AI technologies and attribute more intelligence to them than they actually have. Next, I want to highlight a few of the design considerations that we identified in the literature. One of the design considerations we identified within the What is AI theme is to consider including graphical visualizations, simulations, explanations of agent decision-making processes, or interactive demonstrations in order to aid in learners' understanding of AI. Several existing design education initiatives have explored embodied interactions as a way of helping learners to make sense of agents' reasoning processes. Designing to facilitate embodied interaction may involve embodied simulations of algorithms or hands-on physical experimentation with AI technology. And within the space of how do people perceive AI, providing opportunities for individuals to program or teach AI can also aid learners in understanding how it works and recognizing the role that humans play in AI development. However, when providing these opportunities, it's important to keep coding skill prerequisites to a minimum. There are a number of strategies that have been explored in the CS education space that can aid in minimizing programming skills necessary to program or teach AI, thereby sort of lowering the barrier of entry for individuals and broadening access to AI education to individuals who may not have the experience or know how to program. Finally, leveraging learners' interests, such as current issues, everyday experiences, or common pastimes like games or music, can help to engage learners who may not otherwise be interested in or feel included in AI. It can also help in highlighting the relevance of AI to everyday issues and concerns. So to summarize, we have synthesized a wide range of interdisciplinary literature in order to identify a set of competencies that clearly define AI literacy, a term that currently lacks a cohesive definition in the literature. We have additionally identified a set of design considerations that can inspire and guide the design and evaluation of future AI literacy learning interventions and learner-centered AI technology. Finally, we hope that this framework is the beginning of a conversation surrounding AI literacy. We intend for this framework to serve as a jumping-off point for future empirical and design research, and we anticipate the need for modifications or expansions of this framework to accommodate new findings, technologies, and rapidly changing social norms. Thank you so much for your time, and if you have any questions, feel free to reach out to me.